All right, so we're going to be looking at box plots, and the nice thing about box plots is that they tell us a little bit different, or they tell us about our data in a little bit different way than, say, a bar graph or a frequency histogram would. Okay, here we have frequency histograms, although this one they kind of made improperly. What's wrong about this?
Oh, they're touching.
They're touching, yeah. They shouldn't be touching because this isn't continuous data. If it was meant to be continuous data, they should have labeled either side of those bars, right? It should have been like one here and 2 here and 3 here. Okay, but anyways, you guys get the idea anyways. But the nice thing is that the box plot can help us see things like symmetry when the histogram is a little bit unclear. Like the symmetric distribution that they have up there, you'll notice if we just follow, let me make that a little bigger, okay? If we just follow this, you could tell it's mostly symmetrical, but then you got these questions about like, well, what about this guy? He's really low, you know, and then this guy is pretty low too. You know, could this be skewed one way or the other? But if you look at the box plot of this data, what are some things that you notice that kind of tell us this is probably symmetrical?
In the middle.
What's in the middle?
The box.
Okay, the box is in the middle, meaning that, you know, if you look at the whiskers, they're about the same length, right? So that puts that box right in the middle of our data, which makes sense. It should be the middle 50%. If it's symmetrical, then it should be actually in the middle of our range as well.
And the median is also like in the middle of the 2 quartiles?
Yeah, that's right. The median is in the middle of that box, okay? So you've got these 2 quartiles on either side. The middle 50% is kind of evenly spread. And then the outer 50%, or the lower 25 and the higher 25, are both spread out about the same amount on either side of the middle 50. Okay? So here, it's actually easier to tell it's symmetrical by looking at the box plot than it is to look at the histogram. Okay? Now, with the skewed data, notice this is positively skewed because these couple of high values up here, the 7s and 8s, are going to skew our mean to the right. Okay? Now notice here, the median is 3. The mean would probably be this way a bit. Okay? Now this one, I think we calculated it, and it was like 3.2 something, which doesn't seem like a whole lot. But when you look at this, notice this whisker is much longer than this whisker is, okay? You know, so you have a skewing. For the negatively skewed one, you know, you have the vast majority of the data up here, and then it really drops off and you've got some really low ones, okay? This is actually probably what a lot of the grade distributions look like. A lot of people up in the, you know, B to A range, a fewer C's, and then it trails off just a couple of D's and F's. Okay? Sorry, what were you going to ask?
Why wouldn't it be the opposite way? Like if you're going from high grade down?
Well, here, when we're talking about skewing, we're talking about what is happening to the mean. Oh, thanks. There we go. It's back. When we're talking about skewing, we're talking about what's happening to the actual mean. All right? So we have this collection of data up here. It's a little overkill. That's where the vast majority of our data is. Okay? But then you've got a couple of these that are, really small, really low values. And what that's going to do is that's going to pull our mean down, lower than where the majority would kind of indicate it would probably be. And this is a case where the median score would be more useful. Okay? Looking at our box plot, the mean might be down here because of all these low scores pulling it this way. Okay? So again, when you're talking about skewed data, you've got to think in terms of what's happening to the mean. Is the mean getting pulled lower than the majority, or is it getting pulled higher than the majority? Okay? Alright, so let's talk about another aspect of the box plot before we actually make any. The outliers. Okay? This is a term we use kind of loosely in a lot of cases, but mathematically speaking, there is a definition for what defines an outlier when we're talking about data. Okay? Outliers are extraordinary data that are separated from the main body. Okay? Now, one question that occurs before we get into actually finding values is, should we include outliers in our data? Okay? And the question is, for you as a researcher, it's somewhat up to you how you handle outliers. Okay? One of the cases where we would definitely eliminate outliers would be, for example, if there were some extenuating circumstances that caused that. For example, in the Olympics recently, there were two, I remember reading about this, I don't even remember what race it was, but there were two ladies who were racing, and one of them kind of tripped up and knocked the other one down, and they both fell, and they were both kind of injured, and they finished like 5 minutes after everyone else or something like that. Okay, if you were trying to analyze the times of the races for that particular event, you would eliminate those outliers because they're going to throw off all your data, and there was something unusual that happened that caused it to be that way. Now, let's say some teeny tiny country that has no Olympic program or whatever just let Joe Schmo enter that event, and they were just really, really bad and slow, and they took 5 minutes longer than everyone else. You would include them in your data, okay? Now, that's where, as a researcher, you then have the option to, you would give the original data, and then you could say, okay, you could analyze that one data point and say, without this data point, these would have been the results, and these might be more reliable as a general rule because of this, this, and this. Okay? One of the keys is just communication. And actually, those of you, if you choose to do any statistics topic for an IA, that's something you would have to consider. Do you have any outliers there, or any data that you feel you could eliminate? And discussing that actually can be helpful in that personal engagement and in your understanding of the topic. Okay? So that's something to consider. But we need to make sure that we can actually identify outliers mathematically. And you'll notice we have a formula here to create kind of boundaries of what the furthest away from our data we would go is before we would start calling things outliers. And you'll notice this here, this 1.5 times the IQR. And I want to...
Upper quartile, the first one or the third one?
It is the third. Okay, the upper quartile would be the third quartile, Q3. And the lower quartile would be your Q1. Okay? I want to kind of define this way because this will, I think, help you understand the formula and kind of simplify it to where you're not just memorizing. Okay? 1.5 times the IQR is going to be the maximum length of a whisker. Okay? It's the maximum length of a whisker. Now, if you look at this data down here, each of these units represents a half. Okay? So right here, what would we call this value here at 6.5?
First quartile.
Good, that's our first quartile. Alright? And 8 would be our what?
Or second quartile.
Also known as
Medium.
median. Good. And then the 10th,
Third quartile.
okay, that's our Q3. 10 is our Q3, our third quartile. Now, what's the max value of all of our data?
14. No,
16.
16, okay.
That's an outlier.
There's our max, okay. And notice our min is down here at 1.
They're both outliers.
They are both outliers. Okay? Now let's look at what defines this outlier. First of all, we have to know the IQR. So what is the IQR? Okay? Yeah, 3.5. Alright, that's the distance from 6.5 up to 10, so that's 3.5. What's 1.5 times the IQR? You guys can do this.
5.25.
5.25? Okay. So 5.25. That's the longest either of the whiskers will be. Okay? So if we go, we have this bottom whisker here. It starts at 6.5. So the furthest down we could possibly go would be how far?
1.25.
Yeah, 1.25. So here's 1, our min, and then 1.5. So 1.25 is right here. Sometimes I'll write a little dotted line there, just so I'm sure. Okay? Now, notice our min was below that, so we put a little star, or you could put an X. It doesn't matter as long as you just indicate that as an outlier. Yes, Kate?
So we put the dotted line so we know that the value is outlier?
You don't have to draw the dotted line. I just drew it as we're explaining here. Okay? But then anything past that, you would put an X or a little asterisk or something like that to show that it is an outlier. Okay? The fact that it's not connected to the whisker shows that it's an outlier. Okay? And it's possible you might have more than one. And that's okay. Now, yes?
Sorry, just asking, where did we get 1.5? Is that just like a value that we've determined, or?
Oh, the 1.5 times the IQR? That's just kind of a rule that they've come up with.
Okay.
I'm not sure the origins of it, but. Now, notice though our bottom whisker is not drawn all the way to that dotted line. It's drawn to 3. Okay? So we don't make the whisker go all the way to the dotted line. What do we draw the whisker to?
The minimum, not including the outlier.
Yeah, it's the minimum of the scores that are not outliers, okay? So this is the minimum of the scores that are not outliers.
That's 3, right?
That's this right here. That's what you draw your whisker to. Okay? So I actually know what the first two data points were here. I know I had a 1 and a 3, and then I've got some other values after that. Okay? Because 1's an outlier, 3's the next highest score I've got. Okay? It works the same way on the other end. Okay? If I add 5 1/4 to 10, that takes me up to 15 1/4. So that's right here. So that's my boundary. 16 is obviously past that, so we mark that with the asterisk or with an X. The next highest score must have been 14, okay? So again, you draw this whisker to that value there. This is the max of the scores that are not outliers. Now, one question students will often have is they say, okay, well, won't that affect what my Q1 and Q3 are? The answer is no. Okay? If you are graphing the outliers, you leave your Q1, Q3, and your median all alone. Okay? What you may end up doing, though, is you may want to then draw a new box plot, state a new max, min, quartiles, everything, eliminating the outliers, okay? So if we were analyzing this data and we got those two outliers, we might show this and discuss it briefly, but then we could say, eliminating the outliers, this is what we would actually have. This would be our median, this would be whatever, okay? Now the median actually wouldn't change if you have the same number of outliers on either side, but your mean might change, okay?
So even if you have that outliers, you're still gonna do like you're still gonna calculate the quartiles and median and stuff with
Yeah, yes. Because actually to determine if there are outliers, you have to have already done that.
Oh, okay.
So you won't go back and change it after the fact. Yeah, Kate?
I'm kind of a little confused. So the dotted lines are the upper and lower borders,
Yes.
but when we calculate them, the upper quartile is quartile 3, right? But if we do 16, oh, we do 14, right? Do we do 14 plus? So when I did like 3 minus 1.5 times 3.5, I got a negative 2.25. Anyway, that's not.
Wait, you did what? Oh wait, you did 3 minus the 5.125? No, you're not gonna do 3 minus. Remember I said this is the maximum length of a whisker. The whiskers start at the Q1 and the Q3, right? So you would have to subtract from the Q1. That's where we got the 1.25. 6.5 minus 5.25 is the 1.25. That's that dotted line.
Okay, makes sense. And if so everything we got outside of that, like let's say 16 on that side and something 1 on the other side, we have to exclude them in order to do the new one, to do,
If you were asked to do a new one with only the ones that are, and eliminate the outliers, then yes, you would get rid of those and you'd have to redo everything.
yes, so like we have to redo quartiles, everything.
Yes.
But we take them out from the scale from everywhere, right?
Yeah, you would take it out. Now, you only do that if you're specifically told to, so. Alright. Any other questions? Alright, let's actually make one here real quick, okay? Or analyze one here a little bit, okay? We've got this box plot that we're given, alright? It might be a little bit hard to see, but notice right here, this is at 25, okay? Or let's go through the questions here. It says copy and complete the following statements about the test results. What was the highest mark scored on this test?
98.
Okay, good. 98. All right, 98. And what was the lowest mark?
25.
At 25, okay, so we call that the min. Now it said, half of the class scored a mark greater than or equal to what? 70, okay? Because 70 is the
Median.
median, that's right. Okay, so there's 70. I'll write these in, okay? The top 25% of the class scored at least how many marks?
85.
What?
80.
85, okay? 85. Notice here, here's our Q3. Q3 at 85. It's greater than 75%, which means how much is better than that? 25%, okay? So remember that division here. Remember the box we started out the day with? Okay? Here it's just spread out a little different. Here's 25%, 25%, 25%, and here's the top 25%, okay? They scored greater than 85, okay? What did the middle half of the class score between?
55 and 85.
Yeah, the middle half is the interquartile range, or not the interquartile range, but the between those two quartiles. So between Q1, which was 55, and Q3, which was 85. Okay? So you can see here the way you can just look at a box plot and tell something about the population, or about the people who took this.
Can
Yeah.
you explain 3, please? The top 25%. How do you know it's 85?
The top 25 scored at least how much? If you look at your quartiles, the top 25% would be these guys right here, right?
Mm-hmm.
Well, that's our top whisker. Our top whisker starts at 85. So the top 25 are all at least that value.
Thank you.
Okay. All right, so now what's the range for this data? Yeah, 73. 98 minus 25, 73. And what's the IQR for this? 30. Okay. Now 30 is kind of significantly lower than half of the total range. And we can already kind of see this, but notice that happened because of what?
25%.
The what?
25%.
What about it?
The
Oh, person, you're saying.
yeah.
Okay.
The guy who scored like really bad.
Yeah, this range down here, this bottom 25% was spread out a lot more. So that increased our overall range, but our interquartile range was smaller because that middle 50 was grouped a little bit closer together. Okay? Now question, is that person who scored a 25 an outlier?
Well, no, because the whisker goes to it, right? Yeah.
Well, yeah, we can tell because of how it's drawn, but what would our bottom value for an outlier be?
It wouldn't be a 25.
What's our IQR?
30. So it'd be 45, right?
45 below what
yeah,
value?
Below Q1.
Below Q1. So the lowest we could be and not be an outlier would be
10%.
a 10. Yeah. Yeah, that would be our lowest. Whoop, 10. And the highest would actually be 45 plus 80 would be, 130. So there's no way we're getting any outliers up there. Okay? And that's possible. That's I mean, it's possible to get, theoretically, the highest we could get would be a 130. Realistically, though, we know that's gonna be impossible, so, and that's okay. Alright, does that make sense? Okay, so for Thursday, only the required IP for day 3. Day 4, we're gonna work in class together to do some after we do our survey, okay? We all good?
Good.
Alright, great.